Good morning, friends. So we'll start computed tomography, part level 3, study guide. General principle of computed tomography. So computed tomography CT differs from conventional radiographic image. In the CT image, eliminates the overlapping of structures, whereas conventional radiography, it is a projection through one angle and therefore the material overlap. To generate a CT image, the X-ray transmission is measured by detector and data is obtained from many viewing angles. A computer mathematically reconstructs the cross-sectional image from the multiple view data collected. This reconstruction image is a two-dimensional presentation of two-dimensional cross-sectional cut-through object. The number of slices are reconstructed, then a three-dimensional rendering of the object may be obtained. This rendering may then be sliced along an arbitrary plane or outer layers of the object removed to reveal internal details. Therefore, CT is an ideal examination technique where when the goal is to locate the size planar indications in three dimensions. Illustrations how CT works. Understand by this. Okay, ray interaction with material, mathematical basis. Tomography has been demonstrated using many different physical modalities. Essential technological requirement is that a set of systematically sampled line integrals of the parameter of interest be measured over the cross-section of the object under inspection. That of the geometrical relationship of these measurements to one another be well known. However, the quantity of resulting reconstruction depend on at least three major factors: how finely the object is sampled, how accurately the individual measurements are made, and how precisely each measurement can be related to an absolute frame of reference. Data sampling principles. Integration of mu s ds. ln I0 by I0. Mu is the constant of proportionality. I0 intensity of attenuation on attenuated radiation, intensity of transmitted flux. Physical limitations of the sampling process. The quality of the reconstructed image depends on the quality of data generated by scanner. In actual practice, equipment and methods are limited in their ability to accurately estimate the line integrals of the attenuation through the object. So some of the more predominant sources of inaccuracies are photon statistics, beam hardening, finite width of X-ray pencil beam, scattered radiation, and electronics. And hardware non-linearities and instabilities, or both. So considerable attenuation is devoted in managing the problems. Reconstruction. The reconstruction problem places a number of severe constraints in the data, as the set of the integral must be represent a systematic sampling of entire object. The size of reconstruction determines the number of unknown and the number of linearly independent measurement necessary to reconstruct an arbitrary object from data in which the dominant sources of noise is photon statistics. Convolution back projection method. So back projection can be thought to be an reversing the data collection process during back position. The value of each sample in the profile is numerically added to all the image pixels that participated in the attenuation process for that sample. Conceptually, back projection can be thought of smearing each profile back across the image in direction of the radiation propagation. Basic hardware configuration. Operator interface, source of penetrating radiation, radiation detector, manipulation, mechanical scanning assembly, computer system, image display system, and data storage. Operator interface, radiation source, CT scanners, X-ray tubes, linear accelerators, isotopes. The test object, radiation source, detector, mechanical assembly, computer graphical display system, data storage. Typical component, computed tomography system, radiation detectors. There are essentially general type of detectors widespread use. Gas ionization detector and scintillator counter detectors. These can be either linear arrays, area arrays, mechanical scanning equipment, computer system. So there is source, object, and detector. Source, object, detector. ABC. Image display and processing. Achieve Achievable data storage. Information such as image data, operating program parameters, part identification, operator comments, slice orientation, other data are usually archived in the computer readable digital format on some type of storage medium. One standard image storage method is digital image communication in unrestricted evaluation dicontent described in STM 2339. Scan geometries system configuration. So there is this type CD. Computed tomographics A first generation, second generation, rotate and translate C third generation, and D fourth generation volumicity limited angle tomography are not depicted. So rotate and translate tomography first and second generation. The rotate and translate schemes uses single source and bank to detect arrange to sustain the fan beam of source. The fan beam is collimated so that the fan lies in the plane of interest. So this allows all views that within the fan angle of the source to be obtained on the same traverse. After traversing the fan, the object rotates the number of degrees of the fan and traverses back across the fan beam. Rotation continues until 180-degree minimum or 360-degree better have been covered. Rotate only tomography, third and fourth generation rotate only tomography also uses single source and bank of detectors. The Swanson test specimen as seen in the source. Detectors provide a single view simultaneously, and the view consists of series of fan-shaped measurement rather than parallel X-ray measurement. By continuously turning the test specimen and taking the data, many fan views are acquired for reconstruction. In rotate-only scanning, the detector will not see the entire object. As in rotate and translate, the detector imbalance causes ring artifacts in the image. Both methods use a collimator fan beam of X-ray and one-dimensional linear array detectors. The rotate and translate scheme is commonly used for industrial object because object larger than X-ray beam fan angle can be accommodated. The rotate only scanning approach is used on small industrial object because it is faster than rotate and translate. Both method image only one slice through the part in a single scan. That slice inspection volume in the size of fan beam height collimation. However, by translating the object or a source detector perpendicular to the fan beam, number of slices can be collected and three-dimensional data obtained. Volume computed tomography. Volume city or cone beam city uses a two-dimensional area detector and an uncollimated cone of radiation such that entire object may be tested on in one scan. Techniques sacrifice some details in the image quality for higher throughputs, and the entire object must be tested and has limitations placed on applicable part size. It generally works well only for relatively small object. Limited angle tomography. So limited angle tangential and annular reconstruction CT are methods that can be beneficial to large composite structures. Limited angle CT doesn't require that CT data be taken from all angles completely around the part. It can be particularly advantageous for large planar composite structures. Tangential and annular reconstruction offer advantages of large cylindrical structures where information is needed only along the annular ring, particularly near the outside structure. However, the reconstruction are not as accurate. CT systems performance parameter, modulation transfer function. The modulus of one-dimensional Fourier transformation of a profile through the PSF gives the modulation transfer function MTF of the system, which describes differential ability of the system to reproduce spatial frequencies. In general, low frequency large homogeneous features are reproduced more faithfully than high frequency small features. Spatial resolution. The resolution is defined as a minimum separation detection. Ability to sense the two features are distinct. Contrast sensitivity. A signal to noise ratio is an important measure of system performance. The values improve with higher signal strength. Large slide thickness and longer scan time will also improve signal to noise ratio. Signal to noise ratio will also improve with smoothing algorithms in the reconstruction. However, this will decrease the resolution artifacts. And there are artifacts also, mechanical inaccuracies, material densities, partial volume effects can also produce harsh effects. And circular ring in rotate only city system to those that are process dependent. So partial volume sticks. Beam hardening is a primary source of artifacts from polychromatic sources. Then comes reference standard. So a single reference standard until may contain a variety of subsections that will measure various parameters. The parameters themselves are not independent, but often are different manifestation of fundamental performance characteristics of the system. Measuring material density. Alignment dimensional accuracy, image artifacts caused by mechanical alignment, slice thickness geometry, vertical coverage, alignment, and uniformity of computed tomography plane in object, spatial uniformity, variation of computed tomography measurement across scan plane, noise, random variation attenuation measurements measured by statistical variation of noise power spectrum, low contrast sensitivity, ability to detect small contrast changes. This is mainly limited by noise. Spatial resolution, ability to distinguish two objects as separated. Measurements should be under noise-free condition. Modulation transfer function, quantitative measurement of high contrast spatial resolution, effective energy and linearity of computed tomography numbers, monochromatic photon energy that would give the equivalent result as the polychromatic spectrum used, accuracy and precision, reliability and stability of the computed tomography measurement. Computed tomography system attributes test specimen size, weight and shape, mechanical handling equipment, loading and unloading, test specimen X-ray penetrability, X-ray source, X-ray detector type, dynamic range of detector, front-end electronics, spatial resolution, accuracy of mechanical handling equipment, configuration of source, subject and detector source and detector aperture size, detector pixel pitch, contrast sensitivity, length of X-ray source, integration time, artifact level reconstruction algorithm, software, accuracy of mechanical handling equipment, speed computed tomographic process, size of the object, X-ray source, strength, number and configuration of detector, but structure, speed and architecture of processors, mechanical hardware, motors, brakes and others, number of pixels in image, number of configuration of detectors, amount of data accuracy, choice of computer data hardware, slice thickness range, detector configuration, system dynamic range, operator interface, instrument control panel, image processing system, control software interface to remote workstation, archival requirement, choice of computer and hardware, reference standard, categories and measurement techniques, spatial resolution, whole squares, line pairs, pins, wires, modulation, transformer parts, function calculations, control, signal to noise in a uniform material, sample, small density variation, material density, various solids, liquid and different mixture percentage, porous material, compaction, dimensional accuracy, distortion, pin set, hole set, since slice thickness, pyramids, cones, slanted edges, spiral slits. Okay. An example might consist of an acrylic disc with inserts of 10 various material. Dual energy CT can be used to solve for density and atomic number. System design traces the sensitivity to fine detail CT system is a function of resolution and contrast sensitivity. CT resolution is fundamentally determined by the beam width of X-ray optics design in one direction and driven by selection of source size and beam filtering, detector aperture size, source object, the detector distance and the pixel. Pitch of the detector in other direction, the beam width, size of the object and image reconstruction matrix must all be considered in a system design. In a cone beam area detector type system, the beam width is the height of each row of pixels. Other functions reference standards. Reference standards that represent actual parts that have discontinuities of known dimension are excellent for monitoring day-to-day testing sensitivity and should be implemented if possible. A computed tomography CT system consists of radiation source, detector, mechanical assembly, and computer. CT differs from conventional radiographic imaging because the features are not superimposed. Ray interaction of CT are same as conventional radiography. A set of integrals is referred to as views. A view can be referred to as projection or profile. Back projection, convolution, back projection can be through the reversing the data collection process. Convolution back projection is the most common form of reconstruction. Finite number and width of X-ray beam causes the blurring of features. The blurring function is called the point spread function PSF. The ability to sense the two features are distinct refers to as spatial resolution. Contrast sensitivity referred to as noise graininess of the image. The inverse of the contrast sensitivity value is commonly referred to as signal to noise ratio. Features in image that are not present in the test object are called artifacts. Using a reference standard, material correlation between CT values and material density can be established because of the X-ray attenuation coefficient is dependent on both the density and atomic number. The sensitivity of detail of CT system is a function of spatial resolution contrast sensitivity. Reference standards are used to evaluate various characteristics of a CT system. Reference standards that represent actual parts and have known discontinuities are used to monitor day-to-day testing sensitivity. Okay, I'll stop here.